Alright, now we have another problem regarding buoyancy. Let's read the problem. A block of steel, specific gravity is 7.85, will float. May ganun yung float niya. Will float at a mercury water interface. What will be the ratio of distances A, this is A and B, for this condition? So, we are given a block of steel, tas binigay yung specific gravity niya, tapos lumulutang daw siya sa isang mercury water solution or mercury water interface. We are asked to find yung ratio of the distances A and B, in which A is the part of the block na nakalutang sa water at yung B naman is part of the block na nakalutang sa mercury. And we all know that the SG, specific gravity of water, is equal to what? 1. 1 yan, di ba? Tapos, ang SG, wait, I forgot the subscript. SG of H2O is 1. Ang SG naman ng mercury is equal to, remember this, kasi gamit to, 13.6. Alright. And we are also given specific gravity of our steel, which is 7.85. So, hahanapin natin yung ratio ni A at B. So, that's what we're looking for in this problem. So, let's start. For this problem, makikita natin, we have two fluids. Fluid 1 is H2O, and the second fluid is mercury. HG, ano? Yeah. And our block, meron siyang uniform naman yung block natin na steel. So, it has a weight. May weight yung block natin. Pero, dalawa yung fluid. And magkaiba yung specific gravity ng H2O and mercury. So, they will exert two different buoyant force. Buoyant force for H2O and the buoyant force for mercury. They will exert two different buoyant forces sa steel block. And summing our forces in the vertical direction or in the y direction, summation of vertical forces, we will have the equation assuming na pababa is positive. Okay. So, weight of the steel block minus buoyant force ng H2O minus buoyant force of our mercury, that is equal to 0 kasi nga nakalutang yung steel block natin sa mercury and water. Okay, rearranging this equation, we will end up with the weight of the block. The weight of the block is equal to the buoyant force exerted by water plus the buoyant force exerted by the mercury. And we all know that weight is simply the specific weight of the steel times the volume of the steel, and buoyant force is equal to gamma times the volume displaced. So we have here the gamma of H2O times the volume displaced, let's say 1. Ay, A na lang kasi A yung nandito. So, let's use A. Volume displaced, A. Plus the gamma naman ng mercury and volume displaced, B, since B yung draft niya sa mercury. Okay. Now, we know that the specific weight could be obtained through the specific gravity and just multiply everything by the specific weight of water. So, magka-cancel out lang dyan yung specific weight ng water. Pero, para mapakita natin, let's write it down. So, the Sg of steel times the gamma of H2O times the volume. What is the volume of our block? It's simply area times this draft. The total pala. So, we need the area of the block times A plus B. So, it's simply area of the block times A plus B. Bakit? Since we have here a block and hindi natin alam yung lengths niya, but we are given A plus B, kailangan lang natin siyang i-multiply si area para maging unit siya ng volume. Okay? So, hindi natin kasi alam yung area. We are not given any value for area. So, let's just write the capital letter A. So, for gamma naman ng water, this is simply the Sg of H2O times gamma ng water times the volume displaced is, again, the area of the block times the submerged part in that fluid. So, yung nakalutang na part o yung nakasubmerged na part pala sa H2O is yung A. So, lagyan na lang natin dito A. And for the mercury naman, that is specific gravity of mercury times gamma of water and the volume displaced sa part naman ng mercury, again, that is the area times the draft, yung nakasubmerged sa mercury, which is B. So, this will be times B. Kung mapapansin nyo, mga kasama, the common variables will just cancel out. Ano yun? Yung gamma ng H2O tsaka yung area. Nag-cancel out lang sila since common silang lahat. Gamma ng H2O and yung area natin. Hindi naman nagbabago yung area. So, we are left with what? The Sg of steel. What is the value for the specific gravity of steel? We have here 7.85 times A plus B. So, 7.85 times A plus B equals Sg of H2O is simply 1. So, let's just write here A plus the Sg of mercury is 13.6 times B. Okay, rearranging the equation para mas makita natin, solve natin siya linearly. Let's just distribute this 7.85 7.85A plus 7.85B A plus 13.6B. Ayan, tas kukunin mo na lang yung ratio ng A at B. So, rearranging, subtract ko to dito, yung A, tapos itong B ay subtract ko din sa kabila. So, 7.85 minus 1, that is simply 6.85A. And 13.6 minus 7.85, that is simply 5.70. Am I correct? 13.6 minus 7.85, 5.75. This is 5.75B. And to get the ratio of A plus B, divide lang natin sila ng 6.85 at saka ng B. So, lipat ko to sa ilalim, tapos lipat ko din to sa ilalim. So, the ratio of A over B is simply 5.75 all over 6.85. Or in decimal form, let's use 4 decimal places. That is 0.8394. 0.8394. This is our final answer. Yan yung hinahanap nating ratio of the distances AB dito sa ating problem, in which a block of steel ay nakalutang sa water at saka mercury solution, or in a mercury and water interface. So the value or the ratio of A and B is simply 5.75 over 6.85, or in decimal form 0.8394. And that would be all for this problem. Ayan, as usual. Okay, thank you.